this year is a very special year for Compact RIO. We are celebrating our 10-year anniversary for Compact RIO, and it's been a privilege for all of us at NI to watch some of the challenging applications that you've solved using Compact RIO. And to show that, I'd like to play this video, the montage of the last 10 years of how you've used Compact RIO, and some really cool applications that, that you guys have solved. One thing that we've noticed is that across this last decade, you always are looking to push the limits, push the boundaries. You want to add more sensors, you want to add more custom algorithms, and you want to add more processing power. And so to do that, we are always looking to work with you and evolve the platform so that you are able to innovate over the next decade and deploy these systems in a distributed manner over vast distances or in extremely harsh conditions. Now, across this common thread, like I told you, the processing power is needed. And so for this, I'm very happy to introduce today our next Compact RIO, the Performance Compact RIO that, that we announced today. So for this, we have a demo. But before the demo, I got a little click happy, so I'm going to go back. So the Compact RIO, we have added the processing power. For this, we have added an Intel dual-core processor to really increase the processing power of this Compact RIO. To put the Compact RIO to test, we built a really cool demo wherein it is inspecting steel balls. So to show that, we've had 2 cameras that is connected to the Compact RIO and measuring the size of the steel balls. After that, it is giving that to a 10-axis motion wherein that is controlling the jaws to sort these steel balls by size. Now, one thing that we did do was to add in more and more power. We also added more synchronization. So any smart machine needs synchronization to do the movement and synchronize it with the I/O. And so to do that, what we did was we built this demo, and let me run the demo real quick. So here, you can see the jaws are moving in, and they are synchronized. And you'll notice that they are essentially doing this high-speed movement, and they are synchronized so closely so that they are not hitting each other. If the synchronization were to ever falter, they would hit each other and essentially destroy themselves. The other thing that you would notice is the LEDs on the jaws. We also use the LabVIEW FPGA for the LEDs to synchronize them and essentially give you a perception of a cylindrical display. And many of you may have noticed the smiley face that came in on the jaws as it was spinning. So these jaws are essentially very synchronized, like a high-speed dance, like a tango, if you will. And so that's what we're demonstrating using this demo.
I think that's a really impressive demo, Arun, and I think it really highlights the performance that you talked about that we really wanted to deliver with the new Compact RIO system. You also mentioned that one of the goals was to really improve the simplicity of designing these systems. Can you talk about some of the features that would help in that area?
Sure thing, Joel. One thing that we did do to help out the embedded designers, in addition to helping them perform advanced control analysis, is to reduce their need to add more and more subsystems. In today's machines, there are so many complex subsystems that they're getting added, like a motion system, a vision system, and a HMI system. So with this new Performance Compact RIO, you don't have to have a separate HMI system by itself.
So if you're developing a system that would have a controller and an HMI, you could actually develop the HMI tasks and the controller for the Compact RIO in the same program?
That's correct. Now, you don't have to create separate VIs for them. All you have to do is put the deterministic task and the HMI task in one VI and connect the monitor directly. And we are able to make use of the built-in GPU on the Intel dual-core Atom processor that is on the Compact RIO. Now, one thing I do want to remind everyone is that it is not just the processor that makes this possible. It is the LabVIEW RIO architecture of the processor, the FPGA, and the I/O all working in harmony to make this possible.
Well, I think that's a great example of how some of these innovations can help make developing these systems a little bit easier. Now, Being here in India, I know one of the very hot topics where there's a lot of focus is on manufacturing. Arun, can you talk a little bit about the Lavia Rio architecture and how it can be applied towards realizing some of the visions of the factory of the future?
Absolutely, Joel. For this example, I like to use Airbus. Now, I'm sure every one of you here know Airbus, a big aircraft manufacturer. You've probably used the Airbus, flown the Airbus to get here or wherever you want to go. Now, Airbus has this big vision of factory of the future. They want to really revolutionize the manufacturing and improve the efficiency and productivity of manufacturing. And so to do this, they've embraced two things, Internet of Things and smart machines. And to kind of render the future out, they shared with us a video which I found very, very inspirational, and I want to play that for you. Wasn't that impressive? Now, that's what they want to get to. And remember, one of the things that Airbus is dealing with is, well, the main thing that they're dealing with is putting together these aircrafts, and which is one of the most demanding production areas in the world. And in order to do that, they have to work with so many different systems. And so they think that in order to achieve this factory of the future, they have to embrace the latest technologies coming out from the communication systems and the computing systems and really realize the future.
So we've talked a lot about kind of the Internet of Things and the importance of communication. So can you talk a little bit about how Airbus is planning to use communications and kind of the Internet of Things in this factory?
Absolutely. Now, Airbus, like I said, has many subsystems. They have smart tools, they have wearable intelligence, and they have advanced mobility platforms and advanced robotics. And their vision is to be able to reuse the code across all of these things and essentially build cyber-physical systems and smart machines. But as they attacked this project, they were really looking at these subsystems in isolation. And what they quickly realized is that making these subsystems talk to each other was getting really difficult, and code reuse was almost not possible at all. And so they completely reevaluated their approach, and they decided to go with a platform-based approach. A platform-based approach is what allows them to really do a code reuse. So they developed a software framework, or an SDK, if you will, so that they can they can do the code reuse and really focus on critical control algorithms and other IP, such as vision, filters, motion, those kind of things. Now, one key thing that they wanted to do was that they wanted to reuse that code without having to rewrite them completely. And Joel, as you know, one of the strengths of graphical system design platform is the fact that you don't have to rewrite the code. You can pretty much take that same code and use it within LabVIEW, and thereby you're saving a lot of time and effort by reuse.
Now, I understand you were able to get an example from them, something we can take a look at?
Absolutely. So why don't you go to the last table over there, and I have a glass for you. If you wouldn't mind wearing that for me.
No problem.
So I think right now, Joel's glass should be, it has a camera on it, and we should be seeing that up on the screen. And what you will notice, Joel, is that when you go onto the factory floor, imagine that you are a worker in Airbus, and you're going on the factory floor, and you will be looking at, say, a control wing box of an A330. There are over 400,000 points where you need to drill, you need to measure, you need to tighten this, the screws, etc., etc. So it's an extremely intensive task. Now you can see this is the glass that their workers will be using in the future, where it is streaming the video directly from the glass, and then it is using pattern matching to be able to figure out what panel that they are looking at, and then in real time display it here. Now, since I was not able to move the control wing box here, it was just not feasible, what we did was we recorded a video. So let me go ahead and play that video here. So in that video, what you will notice is that, we can get the video up, what you will notice is that, there we go. So this is the video, and what you'll notice is that the worker actually is having the smart glass on him, and then he's going up to the different panels, and through real-time processing, it is able to identify the different points that they need to tighten, and then sending it back to the display. In addition, it can also synchronize with what exact part it is and tell the worker what exact task that they need to be performing. And to do this all, they really wanted to use NI platforms.
Now, Arun, people might be wondering here how the LabVIEW RIO architecture is being used, because I clearly don't have a Compact RIO on my belt.
That's correct. You are not wearing a Compact RIO on the belt, but 2 months back, you would have been wearing a Compact RIO on the belt, because that's where they started their development with. But when they shared their plans of using wearable intelligence, we realized that they are the perfect candidate for our new NI system on module. The new NI system on module is a LabVIEW RIO architecture, and I in fact have it right here. This is the LabVIEW RIO architecture, our smallest form factor yet, that we announced in India recently. And so now, since they started with Compact RIO, they were able to quickly take the same IP and move from the development part to the deployment. Because as many of you know, and Joel, I'm sure you know, the basic tenets of the hardware, of the LabVIEW RIO architecture is to be able to give you a consistent deployment experience from development all the way to deployment.
And is Airbus happy with their progress that they've been able to make so far?
Absolutely. The factory of the future is a big vision, and even for a company the size of Airbus. And so what Airbus has realized is that by using a platform-based approach of using LabVIEW RIO architecture and tools like LabVIEW and the system on module, they were able to achieve a 10x deployment, 10x reduction in the development time as compared to other approaches.
Well, thanks for sharing. That's an incredible example that you were able to share with us for Airbus. Now, we've talked about the factory of the future and all of the innovation that's happening there. Another trend that we're seeing are factories and plants wanting to monitor the health and the performance of their expensive assets, things like heavy, rotating industrial equipment. Arun, can you talk a little bit about this trend and maybe some of the underlying technologies that are enabling this to happen?
Things in Internet, one of the things in the industrial Internet of Things is that there is the cost of sensors and the cost of computing platforms are rapidly going down. So people are able to use them to monitor more and more of their assets. At the same time, the performance of these computing platforms are increasing. So people are able to continuously monitor their assets. The flip side of this is the fact that there is so much data that is being generated. And then you have to also manage all of these different acquisition systems. So this is what I call, and we at NI call, the big analog data challenge.
And what are some of the things that NI is doing to help address the challenge associated with big analog data?
Now, Joel, this is a problem of scale because, again, remember, so much data to manage and so many acquisition systems also to figure out. And so in order to do this all in one product, we did not have any product actually at the enterprise level, but that is until today. We are very happy to introduce NI Inside CM Enterprise for condition monitoring applications. So this is a software-based solution wherein maintenance experts can come in and log in and quickly look at their different assets, acquire the data, and visualize them, generate any alarms, and concisely diagnose the problem and prescribe any kind of preventive maintenance, thereby increasing the uptime of their factories and also saving lots of money.
Great.
Now, I know I've been talking quite a bit. Why don't we actually see the product in live? So to do that, let me introduce Raviteja, and he'll walk us through the demo.
Welcome, Raviteja.
Thanks, Arun. Good morning, everyone. So here we have a small representative setup. So we have two miniature systems present here. So these represent the heavy machinery, rotating machinery that is typically present on a factory floor or a power plant. Now, these machines have sensors mounted on them, like accelerometers, tachometers, which measure the speed, as well as linear displacement sensors, etc. Now, we have two machines here. One of them is a good machine, and the other one is a bad machine. So the bad machine is bad in the sense that it has a lot of vibration. Now, as a predictive maintenance engineer, one would like to compare the data of vibration from both of these machines. And remember, these machines could be anywhere from kilometers to several hundreds of kilometers from the server location. For example, in a wind farm, they would be very far, and they would be inaccessible. So it may take anywhere between half a day to multiple days for a predictive maintenance engineer to actually go to the site and analyze the system. Now this inside CM, what it does is, it acquires data from the machines, the vibration data, the temperature data, all the data, and all that data is stored and acquired by the Compact RIO, which is present here. The Compact RIO then streams this data periodically to the inside CM server. Now, inside CM server, as I said, can be located at a completely different location. Now, a typical task for a predictive maintenance engineer would be to view all the data, all the accelerometer data, and analyze the data for all the faults. Now, typically, it would involve comparing multiple assets and then seeing which one is performing better and which one is not performing better. So let me show you how it looks like. So in front of me, I have the Inside CM Data Explorer open. And this is how a predictive maintenance engineer looks at it. And as you can see, there is a site map and multiple heavy machinery which are listed underneath it. And in this particular scenario, I have a bad fan and a good fan. And from the bad fan, let me just take in a historical data of the RMS vibration value. As you can see, over multiple dates, 16th, 17th, 18th, it has continuously logged the data, and this is stored as a TDMS file on the server. So the engineer could remotely log into the server and then view all this data. You can also see that there are analysis that he can perform, like FFT, RMS averaging, peak to peak, etc. All the visualization required for the engineer is available on this interface. So I have the good fan data, and then let me just drag the bad fan data. So you can see the red trace represents the vibration from the bad fan or the bad turbine or the bad machinery. And the blue one represents the fully functional good machinery. Now in this way, the predictive maintenance engineer can actually find out about the machine remotely. Now this is just one aspect of condition monitoring, which is continuously monitoring machines when they are in steady state. Another important aspect of condition monitoring is to get a real-time update from the machine, especially during startup and course down. Now, in order to simulate that, I have a fault simulator here which generates vibration data. In order to see that data real-time, so I switch on to the Inside CM dashboard, and then I have the alarms and everything configured. So alarms would actually send an email message to the persons whoever are configured in the Inside CM server. So Joel, why don't you just simulate the transient?
I've learned not to turn this on too much.
Yep, perfect. So I log in into the system, and then there is a live alarm update here, which says the machine fault simulator has an alarm.
Actually, yeah.
So as a user, I see this, and yes, you would have received.
And I've also received a text message indicating the same.
Exactly. So the alerts like this, which are sent over internet, as well as the data dashboard that you see here, these alerts help the engineer to monitor all the sites remotely and their assets remotely. Now, you might be wondering, what is this interface? Now, what I have shown you is only the user side of things. There are a lot of configuration which goes from a system administrator point of view. So a systems administrator or the manager needs to continuously monitor the data as well as make configuration changes and updates. Now, I can actually view all my online devices in this web browser application. So this application runs on an Internet Explorer, and it can be opened again from remote location. I can see all my devices, which are listed here. In this case, let me just go to the machine fault simulator. And here, I can configure a lot of settings. What do these settings include? Sampling rate, the duration of acquisition, how periodically should it update the server. So all these things. So all the inside condition monitoring related functionality is given as a single package. And this truly is an example for big analog data solution.
Thanks, Raviteja. I think that is a great example of how managing and configuring and monitoring potentially very large condition monitoring applications is made much easier. Thanks.
So with one thing I do, yes, you can applaud. That was a really good demo. Now, one thing I do want to mention here is that this, because of lack of time, we are not able to show all the different features of the NI inside CM, the different data explorer opportunities that we have, options that you have to display all the data, so on and so forth. But I can assure you that with the biggest pain point for deployment being the vast amounts of distributed system, inside CM being a configuration-based tool, it really allows the embedded designers to take advantage of this configuration-based tool and be extremely efficient at what they're doing.
Well, Raviteja and Arun, thank you guys so much. It's great to see all of the innovations that are happening on the Lavia Rio architecture.